Hello and welcome to our biweekly core protocol sync. Um, we will be having a bit of a new format this week. I'll be facilitating it. Nazar usually is, and he will probably take back over facilitation here in a bit. So we'll go ahead and just jump in with a new format, which will be kind of status updates, and then for the first half of the meeting, then discussions around what's coming up for the second half. So we can go ahead and get started. Nazar, would you mind kicking us off?
Yep, and let me share my screen. Oh, here's Daria. So I think we were planning initially to have MVP of the consensus 2.3 ready by 21st. It kind of happened. It was submitted on 21st for review. It's a big one and difficult, so it wasn't reviewed yet by anyone. But hopefully someone was already taking a look. I know Shamil was trying to run it, and after some attempts, he was successful, which is kind of a good sign. Um, it's a big pull request. It has several sections. I was trying to outline in the description what those sections are and what they do. And eventually, we have a version with some of the details described that basically is consensus 2.3. There are some differences. We had to increase the time slot to 3 seconds from one. Otherwise, we're just not able to produce a proof. And we had to decrease the number of pieces in sector from 1300 to 32. Otherwise, again, it just takes too much time. And there are next steps. The big ones are to just improve performance by a bit, by quite a bit. Otherwise, it is not really usable. Um, so that is the biggest takeaway from the current design. Um, Auditing is great. Plotting is acceptable. Proving is really, really slow. We just physically cannot do it in 1 second. And we have a few parts of the proving process that can be cut in half, basically, but not all of them. So there are still kind of open questions whether we will have to change the parameters. I had one proposal which might not be feasible on the forum about how to change the plotting process. There is, I guess I can share it here. I was doing some profiling, and in here there are some perf results. So basically, the very first item is internal function from the KZG stuff. I don't think you can actually make it smaller. This is an assembly function. Then the second one is actually from Chia proof of space. I think we can probably remove this. I'm not entirely sure, but maybe, depending on where it comes from. And then to the next after that, which are much smaller in magnitude, are from the fact that we are doing the plot in a specific way and we have to count zeros and do some other stuff. So I think we can cut Chia in total in about half. Maybe we can do some other optimizations, but this is a big thing. And it is primarily because of the erasure coding we are doing during plotting, and the number of elements there is just enormous. So yeah, that is the biggest thing I was working on last few weeks, and the results. Now we're just waiting for that to be reviewed and hopefully merged in a few days. And the next priority for me, obviously, is to work on the performance improvements. We have some things to work on immediately. More research needs to be done. That is also working on the other side of this to see if we can improve algorithms. And there is also various ongoing investigations from the testing of Gemini 3D and stuff like that that are popping up from time to time. But those are kind of ongoing team. Yeah. Hopefully by the next meeting, we will have much improved performance on the consensus side.
Great. Shamil.
Last week I had a week off, and before that I was working on the network partitioning for the Gemini 3D. After several iterations, we implemented this feature. we added Genesis hashes protocol version for our system, and now we partition networks by that parameter. For the next couple of weeks, my first task will be investigating some missing pieces that we are now noticing. And after that, I was going to go back to that task to return our dependency of libptp to the main fork, not our own branch. So that will be my main focus.
Great. Rahul, I guess you were also on vacation for part of the last couple of weeks. So.
Yeah, I was out like the previous Friday to last Wednesday. So before I went, I was focused on the benchmarking of the compact block implementation. The initial version had it had a lot of variants, and then I identified an issue the way we look up blocks from our transaction pool. I fixed that, and now we have pretty much constant time latency for the block download, independent of the block size. So I tested from 64K blocks to 2 megabyte blocks. We constantly hit like 300 milliseconds now with after the changes. And there's one other issue I discovered, which is causing us to do like 2 round trips. Like if you take the default substrate implementation, right, it takes 1 round trip. We take 2 round trips because of the inherents, looks like. So what happens is the inherents are not gossiped. So we always incur a miss when we do a hash lookup in the transaction flow. So I have some ideas about how to fix that. Once I fix that, I think it should cut down the latency by pretty much by half, and we should be able to do that in like maybe 200 milliseconds. So that would be the next thing I'll be working on. But before that, I want to get the upstream changes out for review. I had the initial cut out for review last week, and Nazar gave some review comments about I was using the protobufs directly, and I exported the protobufs to outside, external create users. And Nazar mentioned like we should not do that. So I kind of went back and made a change so that protobuf is like internal to the implementation. We don't have to expose it anymore. The changes are done. I'm going to test it and reopen it for review today. This is against our substrate fork. Once I get a LGTM from Nazar and others, I'm going to make a patch against the upstream substrate code base and send it for review. That is ETS today. So while that is happening, I will go back and address the inherent issue today. But one question I had was like our original plan was slightly different. We wanted to do the upstream changes last and make the changes to our fork first, and then integrate the compact blocks, and in the end we do the upstream changes. So now we kind of change course a bit. I was wondering, like, should we start doing that in parallel while we are waiting for upstream folks to respond to make things faster?
Say that last sentence again. I missed it.
Yeah, one second. Sorry, one second. Sorry, there was a noise from outside.
Okay.
Okay.
So what was that? So what would to make it faster?
Yeah, so our initial plan was slightly different. The original sequence was this: we will make the changes, the modular block handler changes to our substrate fork, then do the compact block changes and merge in our tree, then send it for review for upstream changes.
Okay.
So that we can do the integration faster. After the code review, it came out like we want to do the upstream changes first. we want to send it for the upstream review first, and then pull that into our fork, and then do the compact block changes. So I was wondering, like, can we do them in parallel now while we have the upstream changes out for review? Can we also pull that into our fork and start integrating our compact block changes?
Nazar, this question lands to you.
Yeah. Okay. Honestly, I would have expected that we had that upstream pull request opened on Friday, even, or like a week before that. I really would like to see that I don't have to convince anyone to submit a pull request upstream. We don't have to wait for the last moment to send pull request upstream. The goal is to verify that it works for us. Like, if you already can implement compact blocks, clearly it is. Just send to them and let's see what their feedback is. By today, you would have already had some thoughts from them. Maybe it would have been fine for them to have that protobuf exposed and we can hide it later. Or maybe they would have complained about the same thing. We would have had some kind of feedback already. Instead, it seems like we are just going circles, talking about whether we should or shouldn't do something, and it just takes a very, very long time. We absolutely can do that in parallel, but it would be ideal that by the time we have to merge it on our side, we already have some feedback from their side as well. So maybe we can incorporate that feedback into the original merge rather than accumulating more and more diff over time, especially if it's like something fundamental that they don't like. So that is the primary reason. Like, don't hesitate to talk to people, to send pull requests, to have some contributions.
So yeah, my upstream PR should go out today. So while that is happening, what do you recommend? Should I proceed with making changes to our fork, or just hold on until they come back?
So from what I understand, you have already a branch on our side that has both our changes and the changes you want to send upstream. Because you will not send upstream our branch, it has more stuff. So if you have that branch already, you already can submit a pull request in our monorepo that uses that for that branch. And you can showcase like what you are doing on the other side. We can already start reviewing it. And then by the time we review that, we will get some feedback. We will be able to merge the substrate side and then merge the subspace side, and everything will be fine. We can and should do all of those in parallel.
I mean, in parallel. Okay, fine. Okay, yeah, I'll do that. Okay, makes sense. Yeah, I was kind of trying to hold on the upstate change till the end because I haven't done this before and I don't know how long they'll take. So, but yeah, I think I'll have the PR out first thing today. After I address.
I also saw the changes. They are not that massive. I really don't see they will be strongly against it if it helps in some cases. And I think it might be even helpful for them to include compact blocks and other improvements over time.
Okay. That's good.
All right. Daria.
Hey, hello everyone. So in the last couple of weeks, I was also a little bit on vacation because it was Easter. I think it was still in the last couple of weeks. Sorry, my daughter is screaming. I was mostly working on, again, the maintenance of the spec, the making sure it's always in accordance is what we're implementing, helping fix some stuff to Nazar, talking to Chen about the proof. It's been more or less the same for the last couple of months on my side. We have been exploring several improvements to the protocol. I try to reduce size, the time spent on proving in searching for qualities from the POS table. I did not find any obvious solution to that. I have tried another making KZG commitment a little bit faster, but upstream they have fixed it in a different way that has a comparable performance. So that's good. And yeah, we'll keep discussing another stuff, another way to remove erasure coding from plotting as Nazar proposed. Try to get Chen on our side. And I also did the community call last week, which also required some preparation.
That was great, by the way.
Thank you. I should have packed way less info into that.
That was good. Great. Is there any other updates? Yvonne, did you have anything you wanted to share? No? Okay. Cool. We can move into then kind of, there's a few things here for discussion. First, Daria, you just mentioned this, and Nazar kind of in brief mentioned it, this idea with the erasure coding. Do you guys mind having like a 5-minute discussion on what that is that's in the forum? I read through it this morning and saw the conversation, but it might be good to.
Well, the gist of it is that it is slow. We have an erasure coding that is happening on 2 to the power of 16 values, and we like need to recover half of them essentially, and it is just like inherently slow. Like it takes like hundreds of milliseconds, and there is not much we can do about it considering how optimized BLST is, like on assembly level. So the only solution there is to not do it. We kind of can do some parallelization, but we cannot expect people to have a lot of cores, right? On my machine, I have 32 logical cores, and it is a little bit faster than on average machine. But if you go to telemetry, we have 4 to 8 cores on average for our farmers, and we cannot expect them to upgrade massively in terms of CPU. That's kind of against the protocol. But otherwise, they cannot physically prove within the time limit anyway. So the idea was to somehow try to avoid it. But it seems like Chen is not agreeing with us so far. It seems like there are some security implications. But if we can do that, then we not only save on the ratio coding, we also save a lot of computation on other stuff. So that would have been really, really helpful. Maybe we will find another way to get around that. We can potentially decrease the number of elements in half or something like that. But it seems like one of those like hardest bottlenecks at this moment. Hardest to crack.
I have a small question about what you say. You mentioned 4 to 8 cores from telemetry. I wonder, is it a rented machine or just a local machine for user?
I don't know. It seems like mostly virtual machines, but I don't think it matters too much. Like I don't expect people to buy something like a 32-core Threadripper just to farm, where Subspace is supposed to be energy efficient and not requiring a lot of computation.
Yeah.
Okay, so my question is basically, can we manage these requirements, or we just have our limitations for that?
Well, that's the kind of question we are trying to figure out. Daria?
I was going to ask, in that performance result that you have posted, the function that takes 30% of time, this mulex mount, are you sure that's erasure decoding? Because from the name, I would have assumed that would be KZG. So how do you know that?
I just know that it comes from the BLST library, and it is used both for erasure coding and for this. And I was looking at this step-by-step kind of timing, and polynomial reconstruction was taking a lot of time there. So I just assumed it's not necessarily guaranteed that it is that.
The thing is that like the number is 384, which is the number of the BLS curve, which is what's relevant to KZG, rather than erasure recovery that's happening with like FFTs and different things. So that's why I'm not sure. Maybe it's partially, maybe it's not it at all.
Yeah, there is also one caveat to those results. It's perf, so it does sampling and not like exact calculation. So you might have measured something at the time when it was happening, but it was so much higher in terms of the cost compared to everything else that it seems to be related.
Rahul.
Hey, how are you getting this number? Like, are you using flame graph or just plain perf?
I'm just using perf on Linux.
Yeah, I think flame graph will give you a nice like actual call stack and everything. So that will be, I don't know if you can get this integrated, it'll be nice.
Yeah, there is a visualization for perf profiling results. It just wasn't super helpful, so I just attached this one.
Flame graph will give you actual percentages and all that stuff. So I found it very useful in the past. So.
It's the same as perf. Like I looked over telemetry, and it seems like it actually shows like physical cores, not logical ones. So like for my CPU, like I have 12 logical cores, but like 6 physical, and it shows in telemetry that I got like 6 cores. So I believe like most of the people have like either 12 or 16 like logical
Not
cores.
necessarily. If those are VMs, I'm not sure that VM can distinguish hyper-threaded cores from the regular ones.
Oh, right.
And judging by the CPUs, those are a lot of VMs.
Yeah.
I mean, I think that the exact function that you posted is not just the ratio recovery. It's either both that and KZG or just KZG alone. We should look at this closer.
Well, I see no way for KZG to take that much time, honestly, in this case. Just don't do that much stuff.
Could be both then.
Is there a way to look closer to kind of disentangle that?
Yeah, there is, but for me, immediate priority is to try to do something about proof of space. We definitely know that we are doing extra stuff which don't impact the result. We're just like wasting resources. So that is the first priority for me.
Okay.
Yeah. See, maybe you can just comment out the part where it does the erasure coding and see how much difference it makes. Okay. Quick and dirty kind of numbers.
Well, we have a bench, so you can run that bench for proving. You can run it under some profiler or whatnot, and you should be able to capture some results.
All right. Any other thoughts on this before we move on? All right, Shamil, do you want to discuss
Yes.
what you posted?
I proposed some node changes for Nazar today, and I believe that could significantly decrease required connections for each peer, some kind of improvements. However, we disagree on how to establish some kind of required mesh or overlay network. What parameters should it be? And Nazar suggested that we ask our research team to help us in that, to determine what kind of parameters we should use for that proposal and whether it should be feasible in the first place. So I wonder whether Daria could have a look on that proposal and probably suggest us something.
Where did you say you posted it? I haven't seen it.
It's at the
I will
bottom
post
of the
it.
agenda.
Yes, it is at the bottom
okay.
of the agenda, and I will
Yeah.
just directly post it to you or to the research chat.
Yeah, I could post it as a research chat if you're looking for like more, discrete feedback, or to the research forum if you're fine with discussing publicly.
Yeah, I think overall our networking is kind of based on educated guesses by me and Shamil. We are like, think it should work this way, but we don't have a comprehensive from the ground up design, like it should work this way because of this and this, and this is like the paper that has some kind of proofs for it, like what the architecture should look like basically, such that it is like a sound design. Because we are hitting different edge cases, but we don't have a comprehensive kind of similar to the consensus 2.3 kind of document or anything like that.
I know that Chan has included the questions about DSN into like open research questions. So yeah, you can post it on the forum and then post on the research channel like a question, so that we look at that and we can start this discussion. Certainly, we should have a document that's more like a spec for that.
Okay.
All right. Speaking of specs, who posted this PO space spec? Would be
That was me.
Okay.
Yeah.
So would that be a research?
Basically, I'm working with the Chia proof of space. They have Chia Plus repository. And it is C++. As far as I'm aware, it's not the best C++ out there. And I'm not the biggest C++ expert. So it is hard to understand. It also deals with hard, complex topics. And I'm not sure it is the most efficient. So far what we have is kind of like hacking around that implementation and get it to work the way we want it. But it's not the fastest. And it would have been nice if we had actually the spec of what that proof of space should look like. So we can potentially re-implement it, just the components that we need in a readable way and in a way that can be mapped onto specification. The other challenge is that they don't really have like a spec the same way we have, where we can see what needs to be implemented. They have some papers which are like fundamental, not Chia necessarily, and then they have like description that's how they use it in Chia. And then if you go to the implementation, it's slightly different from that paper. So like there is no single source of truth and like good diagrams that I was able to find. And it's really making complex to work with all of that. And we need a much simpler implementation and a very specific one. So if you could have a document that describes these are the steps, these are the things that we need, this is why, I would have been able to implement it maybe faster than modifying this like a third time and dealing with all of the issues that arise from that.
There is a Chia like design document that's last updated 3 years ago. So it's not exactly up to date to the implementation, but I do agree that like for our use case, instead of trying to like separate out the things that we need and don't need from the way they have implemented proof of space, it may be easier to go like from the ground up and design exactly just what we need.
Yeah, my task right now is basically they have 4 phases in the protocol, and we just need the first one. The extra is just a waste of time. They do it because they can shrink the size of the proof of space table, but we don't care about that. So we can already create proofs on the very first one. We just waste resources by going extra mile. And they have proving and verification, which works on the compressed stuff from the very end. So what I need is to rewrite all of that proving that like reverse engineers what it does, all of those extra steps, and just works with the initial table, which is kind of non-trivial. So yeah, would have been nice to not do that.
I mean, if you think that's like out of all the things we discussed, I could make that my priority for this week at least.
The question is how much time you need for that.
Yeah, that is a question.
I can do something in the meantime, but if it takes you like 3 days, I will wait 3 days and do something else instead.
Well, I'm certainly not going to be able to give it to you like today or tomorrow. So if you want to do something else, I would rather, yeah, say you stop like digging into Chia for the time being, and we try to do just pivot to something better. I mean, to still Chia proof of space, but not the Chia implementation of it.
Yeah, the nice thing that if you drop all of the 3 extra steps, the results doesn't change. Like it is exactly the same. So it should be compatible and upgradable.
Okay, so should Daria switch and focus on? I mean, is this something, Daria, you couldn't have today or tomorrow, but by end of week?
Yeah, I could by the end of the week, probably. If I need, I mean, on the Wednesday, I would also meet with Chan and I would before that I would have like a first draft to show it to him and then to see what he has to say about it. So that's also depends on whether I have to redo it completely.
Zara, do you have other things you could focus on while they figure that out?
I think so. I can look into this function a little bit more, whether it's actually called from where I think it's called, and other things. But it is kind of in the critical path for me to usable consensus.
All right. Well, let's plan on Daria midweek. You meet with by the time you meet with Chen, check back. Check in with Nazar where you're at on that, and as our, spend a couple days on the other things rather than jump into the Chia.
Yeah, because I tried to like decompose the Chia as well. It is difficult. Like it's very entangled the way the implementation is done, and the way they're storing their data is instead of the storing the table, they're storing like a table of offsets and differences between outputs. And each phase is kind of sorting that by a different key.
And then
And
you
they
need,
also
during proving, to resort it back.
And
Yeah.
so I need to understand whether we could like not do that at all, and that would still work. So that's the question. In theory, yes.
I mean, in the paper, they write it that like those extra steps are really not necessary. They just know that some of the solutions are simply not used, and that's a waste of space, and that's kind of the thing that they are doing. So they want to get rid of that extra wasted space. That's the only reason they are going these like extra steps, compacting and resorting and compacting it again.
And they also are also storing some sort of pointers from like each table back to the previous table to be able to like prove and verify. And they're storing it in that sort of crazy format with differences. So we have to see whether we can have a better one to avoid this, what they call parks and islands or format at all.
All right. Do we have anything else? That's the end of the things I see in the agenda.
I just would like to ask everyone here to go and actually look at the pull request. It might take a while to understand. If you have any questions or need me to walk you through the implementation, I'm happy to do that. But hopefully we can merge it this week.
All right. Well, we'll say bye to our YouTube watchers. We'll be back in 2 weeks.